I just created one of the greatest games that nobody has ever made before that I'm calling Legally Not Pong. Because my idea is so great and original, I'm worried that somebody might steal it, but I need a way to discreetly distribute it to people for testing. The idea I have is to hide it inside of an image file, and that way, nobody will know that it's actually a game. Just as a quick disclaimer, the techniques used in this video are for educational purposes only and shouldn't be used for hiding malicious programs. To start, I have a Python script for my Legally Not Pong game, as well as a standalone executable. I'll mostly be using the Python script because it's much smaller than the standalone version, and some of these methods are easier to use with small data payloads. The first method of hiding I'll try is really simple. File extensions can be manually renamed, so I can take my .py file and rename it to .png. You'll notice that the icon for the file changes, but there's no preview of an image because there is no image to use. And if we try to click and open it, then we just get an error. To access the game, we could change the extension back to normal, but we don't even need to do that. If we just run the file as is using Python, then it still executes even though it has the appearance of an image. The same is true for the executable, and this one is even simpler because we just run it as an executable and we get the game. While this method does hide a program in something that looks like an image, it's pretty unconvincing because there's no image actually attached. I can't have my file look suspicious, so let's step it up a notch and use a real image. Here I have a picture of a cat, and I'm going to simply append the data of the Python script to the end of the image and name it appended cat. The image itself still totally functions and can be opened, but where's the data for the game? Let's compare the original image and the new image. If we print out the data at the end of the original image, we see that there's this marker, iEnd.b, that shows the image data has ended. Now if we look at the full appended image, we see this. Most of it is nonsense image data, but if we scroll a bit, we can find that same end marker that we just saw. And everything past that point is our Python script. So to get the script back, all we need to do is extract everything after that end marker. We can do that with this command that just finds the marker and makes a new file with all the data after it. And here's our extracted file. It looks like the original, so let's just run it to make sure. Yep, that looks good. Now, that method of extraction was a little more complicated than it needed to be, so let's try something even simpler. Instead of appending the Python file itself to the end, if we append a zip of that file, it becomes much easier to extract. Our new image with a zip at the end is zipped cat, and it opens just fine. Now to get the script back, all we need to do is unzip the whole image, and it will only unzip the zip file at the end. I'll rename it for clarity, and if we test, yeah, still works fine. Alright, let's do one final similar method using something called metadata. There's this program EXIF tool that is really helpful for looking at metadata for images. If we run it on the original cat image, we can see info like when it was modified, accessed, its file size, and more. Some photos even carry metadata like what camera was used or the location of where it was taken. We're not particularly interested in any of these fields, but we are going to add a new field that carries our game data. We'll take a base64 version of our Python script and add it to the comment field of the metadata. This command just added new data to the original image, and now when we look at its metadata, we get a big blob of base64, which is our Python code. As always, the image itself still looks the same on the surface. We can pretty easily extract the code back out and convert it from base64, and we have our Python script again. These methods are good for keeping an original image, but if anyone actually looks at the file data, there's always a giant obvious mass of extra info at the end that totally reveals there's a secret. This might not be good enough for keeping my awesome game safe, so let's go one step further. For the last method we'll look at, we'll make the data extra subtle even at a low-level view of the image by using a method called steganography. At its core, our Python script in any other file is just a bunch of binary data. If we can just minorly alter the binary data of another file by imposing the data of our Python script, then we could store our script with only minor changes to the file itself. This method works really well with images. Each pixel of an image typically carries 3 bytes of data for the 3 color channels. If we alter only the very last pixel of each byte, it makes an imperceptibly small change to the color of that pixel. We then repeat this process until the whole Python script is contained in the image, meaning that if we combine the last bits of every byte in the image, we can recover the Python script. To help demonstrate the effects of steganography, here are 2 small images. One of them is an original image, and one is carrying our Python script. I'm going to use color selection in this drawing program and take a look at a few pixels in each image. Let's get the color at the corner of this star in the original image. Now when we compare to the altered image, watch the hex value. We see there's actually a slight difference, and it shows up in other places too. The images look identical, but when we use the color picker, the steganography is revealed. The easy way to do steganography is with this tool, steghide. We can run this command on the image and input a secret key that's used for retrieving the hidden info. Now if we compare the data of the 2 images, we can see there are some differences just in the header information. And to recover our script, we use the corresponding function. This is a much more sneaky way to hide the game compared to the previous methods, but I really like the idea of a single command that lets us play the game directly from the image without creating some additional file. To achieve this, I've made a custom steganography script that follows the same principles that we just covered, where the least significant bits of the pixel are encoded with the sequential bits of the Python script. For the extraction, a version of the Python script is created and ran in memory, so we avoid making a new file. Just for fun, I also made a most significant bit version, which will hopefully show the steganography more obviously in the image. Here's what it looks like on the cat. It seems like nothing happened, but if we zoom in, we see very obvious distortion at the top, and that's our Python script. There are numerous other methods for hiding files like this, but I hope this was a helpful overview for some of the basic possibilities. Thank you all for watching the video, and thank you to my supporters on Patreon. Until next time.